Hi, I'm Laurel Dunn. I'm an assistant professor and extension specialist focusing on produce safety from the University of Georgia in Athens. I'm actually going to discuss a project that was done in Michelle Daniluk and Keith Schneider's labs at the University of Florida, assessing the prevalence and concentration of Salmonella enterica in poultry litter collected from farms throughout the southern United States. I am going to touch on Georgia poultry production, though, because I am in Georgia and because poultry production is a big deal in Georgia. In 2018, Georgia was #1 in the country for broilers and for hatching egg production. We were #4 for pullet production, and we were #5 for table egg production. So overall, this resulted in a 2018 poultry and egg farm gate value for the state of Georgia at about $5.7 billion. So a lot of chickens, a lot of eggs are produced in Georgia, and with that, a lot of waste material. And the primary waste material in poultry production is poultry litter. And so this is comprised predominantly of bedding, which depending on the region you're in can be sawdust, can be waste products from peanut production, so like peanut hulls, rice husks, things like that. It also includes dropped feed, manure from the birds that are living on the litter, and also mortalities when birds die and either die in the house or are taken out and added to a litter pile. Poultry litter is a very high nitrogen source, and so when it is sold as fertilizer or as a soil amendment, at least in Georgia, the price ranges from about $15 to $20 a ton. In the United States, there are 10.2 million tons produced annually. 2 million tons are produced in Georgia every year. So we have a lot of poultry litter produced in the US and particularly in Georgia. The safety of poultry litter is being scrutinized predominantly because it is often applied to crops. And while sometimes members of the produce industry want to use it, there are concerns about it containing salmonella or other foodborne pathogens that might be conveyed on fresh produce to the consumers. We're particularly concerned about some of these pathogens because once they are introduced into the soil, if poultry litter is introduced to the soil and it contains salmonella, these pathogens can persist for long periods of time, weeks to months, and eventually go on to contaminate produce. And so this can happen when litter is directly or land applied. It can also happen indirectly if you get runoff from rain events, or if poultry farms tend to be in the same watershed as produce farms, you can get contamination of water sources or spread to produce through those avenues. And so while we were assessing the safety of poultry litter and biological soil amendments of animal origin, or BSAAOs, we had a few questions that this project was really gearing up to address. And so one was, how frequently does Salmonella enterica contaminate poultry litter? At what level does this contamination occur, which can be useful for calculating things like die-off rates or determining risk? How long can Salmonella persist in litter? What serotypes are commonly present? Because different serotypes have different characteristics or different affinities for different produce types in some cases. Does contamination fluctuate according to season? And do regional differences account for salmonella contamination? And so going into our methodology, we were particularly interested in the Southeast because at the time I was located in Florida with Michelle and Keith. However, we kind of had to branch out to where the farms were. So we started with Florida, Georgia, and Alabama. And then we ended up recruiting a couple farms from Texas. And so we did this by cold calling some large poultry companies and composters. We used our extension resources. We found contacts at a nationwide conference. And we really kind of hit the jackpot when we teamed up with the State Poultry Association. That's how we had so much success in Southeast Alabama, where we were able to recruit 6 farms. So we ended up with 13 farms in total. And so we had kind of 2 separate sampling methods based on what the situation was at each farm. So a lot of farms would pile their litter in these storehouses or out in the open. And so we would record, whether or not these piles were protected, the depth from which samples were collected, temperature, the facility type, so do they have breeders or broilers, and then just any other storage conditions, weather conditions. And so we would identify 3 piles at each farm. And so from each pile, we would collect 7 samples. 2 of those were toe samples or samples kind of along the edge, usually more like surface samples. And then 5 of these would be gut samples or more interior samples where we would dig into the pile. And so we'd get 7 samples per pile and usually get about 21 samples per farm. Each farm we replicated twice, so we visited once in the fall or winter months and then a second time in the spring and summer months. And then for farms that didn't pile their poultry litter, so if we had to go into the actual house to collect it, we just kind of divided the house into thirds. So we'd collect our first 7 samples from the front, the middle 7 from the middle of the house, and then our final 7 samples we'd collect from the back of the house, just collecting samples from the floor, or in instances where we dealt with poultry or pasture flocks, then we would just collect in kind of the same quadrants, but around the pasture itself. So I won't go into our methods, our lab methods, too much because we don't have a lot of time, but we took 30-gram samples of litter and we initially screened them for presence of or absence of salmonella. So we did this by eventually streaking on XLT4 and then taking any presumptive positive isolates and doing PCR confirmation. And if we got a confirmed positive, then we would begin with our MPN, or most probable number calculation, again using 30 grams of litter, and screening again onto XLT4 with then a PCR confirmation. When we kind of wrapped up the experiment, we sent the isolates off for serotyping. So for our kind of total salmonella prevalence overall, we ended up with 490 30-gram, litter samples collected from 70 piles or surfaces from 13 farms. And so what we found was overall, 6 of the 13 farms, or 46%, were positive for Salmonella enterica. This came out to be about 7% of samples total, so about 33 samples of the 490 ended up being positive for Salmonella enterica. We found that out of the 13 farms, Alabama had 2 out of 7 that were positive for Salmonella. 1 farm out of Florida was positive. Both farms out of Georgia were positive for Salmonella, and one of those farms was the only farm that ended up being positive on both visits. So all the other farms that were sampled were only positive on 1 visit if they were positive. And then 1 Texas farm yielded Salmonella. We found that we collected Salmonella more frequently out of samples that were collected in the fall and winter months, so 12.3% or 32 out of 259 samples that were collected in the fall and winter were positive for Salmonella, compared to roughly about 1% positivity from spring and summer collected samples, or only 2 samples out of 231 were positive for Salmonella in the spring or summer months. Ran a logistical regression and found that Salmonella was 96% less likely to be found in toe samples, or 95% less likely to be found in gut samples, then it was to be found either from the floor of a poultry house or from the ground from a pasture flock. So we were a lot more likely to find salmonella from our pasture flock, ground, or from the actual floor, and not from piled litter. And so we kind of have the numbers here, our nice little easy to read pie charts, where we have 33% prevalence on farms that had piled litter. So 2 out of 6 farms were positive for salmonella when they piled their litter, compared to 4 out of 7 farms that were positive if the litter was just collected from the poultry house or from the pasture itself. And we also found that, again, in piled litter, we had about 3% of samples positive. So 6 samples out of 231 were positive in samples that were piled, compared to closer to about 10% of positive samples when they were collected directly from the floor or from the pasture. So we also found that salmonella was not detected in litter that was older than 21 days. And we found that for every 1-day increase, the likelihood of finding salmonella in those samples decreased by 5%. And so some of this is likely some of the reason why we found salmonella more frequently when collected from the floor or from the pasture, because usually those samples were younger litter samples. Birds had been more recently on those samples or on that litter. So some of the houses either had birds at the time of collection, or if they hadn't, birds had recently been in there and had been moved out, and either the litter was waiting for the next flock or was waiting to be removed, and waiting on equipment or workers to remove it. We also found that a lot of times when we were digging in the litter, especially for the gut samples in those piles, a lot of times the temperatures range from 130 to 140 degrees. This was particularly evident in the winter when you dig a hole and steam would start coming out from the interior of the pile. And so there was some natural composting going on, even though these weren't validated composting procedures going on. Just by the nature of this litter being stacked, it was already starting to undergo that biological decomposition process that was generating heat and likely killing some of those pathogens. We also found that our concentration of salmonella fluctuated greatly among samples within the same farm or even within the same pile. And so we found that we got a range from less than 1 to greater than 280,000 most probable number salmonella per gram. And these again could be, one sample could be the less than 1 sample could be the greater than 280,000, all within the same pile or all within the same farm. So we got great fluctuation in the concentrations that we saw. We also had several serotypes that were identified. And so from Alabama, we had brain drop in Kentucky. Florida, we tended to just see St. Paul. Our Georgia farms, we found Salmonella enterica serotype Kentucky, Michigan, and Seftonburg. And then from Texas, we had 4 different serotypes, including Umbandaka, Kiambu, Anatum, and Newport. So in conclusion, overall, we detected salmonella in about 7% of our samples. Our salmonella concentrations were highly variable within our farms. We less frequently saw salmonella from farms where the litter was piled. So again, only 33% of farms that piled their litter were positive for salmonella, compared to 57% that didn't pile that were positive for salmonella. And we identified 9 different serotypes across the 4 states and 13 farms. And so just kind of a few additional thoughts before I wrap up. For one thing, and this is probably geared towards extension or people that really work with food safety, the produce industry, there is a disparity in the definitions of compost between produce and poultry producers. And we found that consistently while going to collect samples. A poultry producer would not hesitate to offer to take us back to the compost pile when really they just meant the dry stack. And, produce growers, on the other hand, when they say compost, they're looking for that, FDA-defined, scientifically validated process. And some other things. I mean, there are many other factors that kind of confound this and that need to be looked into further. So our poultry litter composition, either the material can make a difference, but we saw differences between our breeder farms and our broiler farms. So that is going to also impact some of the prevalence of some of our pathogens in litter. So if you have any more questions, you can contact me. Like I said, I'm at the University of Georgia. Here's my email. Thank you for listening.